Hey everyone, welcome to Week 8, Module 8. In this module, which is the final module of Marking Period 4, we're going to be covering how to determine the lengths of different arcs when you're given a radius or an angle, be it in degrees or radians. We're going to start off by reviewing what we covered last week, which was how to convert from degrees to radians and radians back to degrees. Remember that degrees and radians are the two units of measure for angles, and you may be given an angle in one of these two different forms. When you're given degrees and you're trying to convert to radians, we have two different factors you could use. Going from degrees to radians, the factor we're going to use is multiplying our degrees by pi over 180. So we have 135 times pi over 180. And you can put this over 1 if you like. So 135 times pi is going to give us 135 pi. And then 1 times 180 is going to give us 180. Now, this is the simplifying piece. So in this case, I'm going to leave it as a fraction, but for the rest of today's lesson, I'll express it as a decimal. So we want to think of what the common factors of these are. So what are some numbers that these can be divided by that they have in common? So I know that since this ends in a 5 and this ends in a 0, they're both divisible by 5. So I know that 5 times 27 is going to give me 135, and 5 times 36 is going to give me 180. So those cross off. Now I know that 27 and 36 can be divided by another number. You can divide it by 3, or the greatest common factor is 9. So if you choose to simplify in a way that's different than this, that's completely fine. This is just my way of doing it. So when we do that, this fraction can't get any smaller. So 135 degrees is the same thing as 3 pi over 4 in radians. And that's that. Now we're going to convert from radians to degrees. So we're given 3 pi over 2, and we want to figure out what does that look like in degrees. So our conversion factor from radian to degrees is to multiply it by 180 over pi. So we have 3 pi over 2 times 180 over pi. So 3 times 180 is 540. We got our pi. And 2 times pi is 2 pi. Now we're going to simplify. These pi's cross off, and 540 divided by 2 is going to be 270 degrees. So 270 degrees is the same thing as 3 pi over 2 radians. Now before we officially start arc length, let's make sure that we understand circumference, because arc length comes from circumference. So circumference is the distance around a circle, and it's a type of perimeter dealing only with circles. It's not the perimeter of a square or of a rectangle, it's of a circle. And the formula for this is 2 pi r. So again, circumference would be this entire distance if we were to go around the entire circle. So let's calculate that really quickly. So our circumference is going to be equal to 2 pi r. R is our radius. If you were given a diameter, so let's say this whole thing was 12, you would divide it by 2. So it's going to be 2 times pi times our radius, which is 6. 6 times 2 is going to be 12. So 12 pi units, this would be our circumference. And this is in exact terms. If you wanted to find it in approximate terms, you would actually evaluate this. So we would do 12 times pi. And when we do 12 times pi, we get about 37.699 units, which is about 37.70 units. And this would be our approximate answer because we had to do some rounding for this to happen. So two different ways to express the same thing. So arc length is pretty much the distance along an arc, how long an arc is. And an arc length is a part of a circumference. So circumference, again, is the entire distance around a circle. Your arc length is just a piece of that. And with our formula, we express that as S. This symbol right here is theta, and theta is our angle. usually expressed in radians. We may have to convert it if it's in degrees. And then the last thing we need to know is r, which is our radius. If we know at least two of these, then we can solve for the last piece. So for our formula, we're given our s, which is our arc length, is equal to our radius times our angle in radians, which you can see right here. When it changes a little bit again is when our angle is expressed in degrees. That would be our arc length is equal to the same thing, except we're going to be multiplying our answer by pi over 180, which is the conversion factor for degrees, which is why we did the conversions at the beginning. So let's do a couple of examples and hopefully you'll feel comfortable with this after that. All right, so in our first example, we're given a radius of 7 centimeters and an angle that is 3.5 radians, and we want to figure out the length of our arc, which is going to be this arc right here. All right, so I'm going to label everything. So we're going to say this is 7 centimeters, and it's 3.5 radians, and we want to figure out S. So our formula is S equals our radius times our radians, or angle. And our radius is 7 centimeters, and our radians is 3.5. So when we multiply that out, that's going to give us 24.5, and it's a length, so we're going to use this unit measure, which is centimeters. And that's your answer. Hopefully it wasn't too bad. Let's go ahead and try another one. So for our next one, we have our radius here, and we have an angle which is measured in degrees, which means we're going to use our blue formula right here. So our radius is 12. Our degree measure is 72. And we're solving for our arc length, which we label with the letter S. All right, so we have S equals R times our angle. And don't forget to multiply by pi over 180 at the end. So S equals 12 times 72 times pi over 180. All right, so when we multiply 12 times 72, that's going to give us 864 over 180. And then I'll just make this a decimal instead of simplifying the fraction. And that's going to give us 4.8. So this is the same thing as 4.8 pi in terms of our exact answer. So remember, this is exact because it leaves pi in our answer. If we wanted to figure out the approximate, we can multiply these two together, and that would give us 15.08 feet. And this would be our approximate. So approximate, and this is our exact answer. All right, so we have two more examples that are up here that I'm going to have you actually try on your own, and feel free to look at the end of the slide deck to see the answers. But this is the last example that we'll do together. All right, so in this example, I'm going to draw it because we want to figure out the length of the radius, not the arc. So just so you could see how this picture is going to look different, I'm going to make a circle. And we are told that we have the angle in radians. So we're going to say this is 3 radians. And we're told that we have our arc length, which is about 20.52 feet. So it's a little different, but if you could set up your equation correctly, then you should be fine. So it's given to us in radians, so we'll use this formula. So S equals a radius times our angle. So we know the S, the arc length, is 20.52. Our radius we don't know, but we know the number of radians, which is 3. So to solve for this, we're going to solve for R. So we're going to divide both sides by 3. And when we do that, we get 6.84 feet. And that would be our radius. And that's it. So we've gone through how to solve for an arc length. We've tried a radius. If you had to solve for the angle and you had radians, it'd be the same thing, except this would be flipped. So you'd be solving for theta. So now that you've done that, feel free to practice, watch this video again, see what you're confused on, and ask us as your teachers questions if you have them. And with that being said, you've made it to the very end. Seriously, you're pretty much done as long as you finished all your work. So good job. We're proud of you and can't wait to hear from you soon.